In this video, we're going to talk about the power of a refractive lens. In other words, what is that little number that comes with your prescription when you're getting your eyes fixed? The units of the refractive power that optometrists use when they give you your prescription is something called the diopter. And a diopter is very simple. It's just really an inverse meter. Okay? So how do you get a diopter? How do you get the refractive power of a lens, right? So the refractive power of a lens is really just 1 over the focal length of that lens when the focal length is given in meters. That's key. So the last few problems we did focal length where we solved it in centimeters. You have to convert that to meters, then just take the inverse, and you have the power of the lens, in other words, the prescription of the lens in diopters, because this is a diopter, which is really kind of a cool unit name, right? Sounds almost like something a transformer would have, 22 diopters. Anyways, we would like to take an example here of my own bad eyes. So my prescription, I am a nearsighted person, my prescription is equal to negative 2.5 diopters, right? So what would be the focal length of my lens? Well, let's take a look at it. This is actually 1 over my focal length, right? So that means my focal length would be 0.4 meters or 40 centimeters. Does that make sense? Good. So in order to practice this, let's just take an example of let's just take an example of the last two examples. How does that sound? All right. How would we turn those last two corrective lenses and the last two examples that we found, how would we turn them into actual, like a prescription, right? If you were an optometrist. So here's the deal. What was our focal length in the first example, the nearsighted example? Well, the focal length that we got in that example was 519 centimeters, right? Negative. But remember, when we are looking at diopters, when we're looking at refractive power, we really want this in meters. So we turn it into 5.19 meters. And let's just round it 2 just to make life easier. Okay, 5.2 meters. Okay, so if I want my refractive power, that's just going to be 1 over this focal length, right? So that's going to be 1 over 5.19, right? And when I do that, I get 0.19 diopters, right? So someone with that vision would have a prescription of 0.1 diopters. Now, I'm not an optometrist, but I think they come in quarter intervals. So this person would probably get a 0.25 diopter lens. Okay. Any future optometrists want to correct me on that? I encourage you to. So that would be, and so that would be also negative, right? By this point, you see a negative prescription automatically implies that you have what kind of eyesight? Nearsightedness. You're myopic if you have a negative prescription. Okay? All right. What about the other example? So the other example, we had a hyperopic person, and that person had a converging lens of focal length 28.4 centimeters. Okay, 28.4 centimeters. As you all know, that's going to be 0.28 meters. I'm just going to round to 0.28. Okay, and in order to turn that into a prescription, we want a refractive power of 1 over the focal length, which is 1 over 0.28 meters. And the value that I get when I do that is 3.4 diopters. Okay, so that is the corrective lens. That is a prescription that somebody would need who had that kind of hyperopia. And notice this is positive in this case, which implies this is hyperopic and not myopic. Okay. All right. This is it in a nutshell. Okay. Now that we have this, we're really primed to answer this finale question of the optometry pyromania. Okay. So once again, I'll revisit this question. Two people who wear glasses are camping. One is nearsighted, the other is farsighted. Whose glasses may be useful for starting a fire by concentrating the sun's rays into a small region at the focal point of the lens used in the glasses in order to save everyone from freezing to death? All right. So who do you want, a nearsighted person or a farsighted person with you if you are on Survivor? Okay. And the answer is we want the person with the converging lens, right? Because the converging lens is going to take all that light from the sun and focus it into one beam, right? The diverging lens cannot do that because that makes the light all separate, right? So now, is it a nearsighted or a farsighted person that has a converging lens? Well, we just showed it in this example right here. It is the farsighted person that has a converging lens. So those folks with reading glasses, typically the old people. So don't count out the old people on Survivor, you know? If nothing else, you can use their glasses. So with that, I wish you all a wonderful weekend and take care, and I will see you next week for another chapter of physics.